In this video, we'll go over a topic called kinematics. This is the topic of physics that has to do with variables like velocity, acceleration, time, and displacement. In only short 5 minutes, you will find out all the equations you need to know to solve any problem in this unit, as well as hidden keywords, tips, and tricks that you need to know to approach these problems. Finally, we'll go over a method for solving this problem. So a step-by-step instruction to approach every single problem in this unit. And in the rest of the video, in the last 5 to 7 minutes, we'll go over 2 practice problems to make sure that you understand how this method applies to problem solving. Let's start by talking about what variables are in this unit. So there's only 5 variables in total. Initial velocity, measured in meters per second, final velocity, also in meters per second, acceleration that is measured in meters per second squared, displacement, which is the distance between final and initial position, and time, measured in seconds. If you have a problem with constant velocity, which means your acceleration is zero, or in other words, your velocity doesn't change, the problem is really simple. You simply use this equation and you're done. Distance or displacement, right, is equal to velocity times time. However, in this video, we talk about accelerated motion. So in accelerated motion, we have 4 equations in total. And notice these 4 equations, all of them have 4 variables. And they're just basically 4 different ways to arrange these variables together. So, for example, the first equation has all the variables except displacement. The second equation has all the variables except final velocity. The third equation has everything except time. And the fourth equation has everything except acceleration. So how do you know how to pick the right equation, right? If there's four of these equations. Well, the method is really simple. You're going to think about what variable you don't care about. Let's say in some problem, you're given final velocity, initial velocity, and acceleration, and you need to find time. So delta x is a variable you don't care about, meaning you don't need to find it and you're not given it. If that's the variable you don't care about, you cross it out, and based on the variable you don't care about, you pick one of the equations. If the variable you don't care about is the displacement, you would pick the first one. If it's the final velocity, you'll pick the second one. If it's time, you'll pick the third one. If it's acceleration, you'll pick the fourth one. We'll practice this method and look at it in a little bit more detail later. But one more thing we need to keep in mind before we approach the problems is these special keywords. So notice the equations on the previous page had 4 variables in each one of them. However, most of the time we will not be given three numbers directly in the problem, because they will try to trick us and code some of the numbers with these keywords. So we need to be able to recognize these keywords. But thankfully, physicists aren't very creative when it comes to writing down the problems, meaning that as long as you know these few phrases, you'll be able to identify what they're talking about pretty quickly. For example, let's say a problem says that something is starting from rest. Well, that means that your initial velocity is 0, right? Because you're starting from rest. You're starting when you're not moving. Let's say a problem says coming to rest, or a lot of the times I see it saying coming to a stop. That means that your final velocity is 0, right? So you should write that down in the problem in the given section if you read any problem. If it says constant velocity, we already saw what that means, right? That the acceleration is 0, and you just need to use this equation. Displacement is equal to velocity times time. This one is less common, but sometimes I saw if something is dropped, that typically means the velocity initial is 0 as well. Maximum height is a very common one. Let's think about what happens at the maximum height. If you throw something in the air, right, let's say a stone, for a second, for a brief moment here, it stops before it reverses direction. So at the maximum height, the velocity is 0. Finally, in free fall, if something is falling in the air, the acceleration, all objects in the air all experience acceleration of negative 9.8 meters per second squared. So feel free to take a screenshot of that, look at it for a second, and let's just keep these keywords in mind as we approach some of these problems. So to summarize, our method is the following. If applied, sometimes we might want to sketch the problem, right? If the velocity is at the angle, we'll find the x and y components. We'll talk about this later, but for now we'll just deal with one-dimensional motion. Then if there's no acceleration, you just need to use this equation. If it is an accelerated motion, then you'll have to write down all of these 5 variables, identify which one of them are given, and remember some of these might be keywords. So let's say we identify 3 variables that are given and the unknown, right? That's the second step. The third one is eliminate the irrelevant, let's say delta x, for example. Based on the variable that we eliminated, we'll pick the right equation, plug everything in, problems are solved, everybody's happy. So now that we have know the method to solve any problem in this unit, let's take a look at some of the practice problems. How does this work in practice? In problem 1, a car starting from rest can reach a velocity of 25 meters per second in only 2 seconds. Find the displacement of the car at that time, then find the acceleration. So for now, let me just focus on finding the displacement. So I will be able to, let me just write down all of the variables. So initial velocity, final velocity, acceleration, time, and displacement. I would just advise you to write all 5 of them, right, in every single problem. So a car starting from rest. Notice again this keyword right here, right? Starting from rest. Reaches a velocity of 25 meters per second. So we started rest, initial velocity is 0. Final velocity is this 25 meters per second in only 2 seconds. 2 seconds, of course, talks about time, right? Find the displacement of the car. So delta x is what we're looking for. And the variable we don't care about is acceleration. So now that we have identified everything that is given, let's take a look at these equations. Again, what is the variable that we crossed out? Okay, I think you see that it was acceleration. So we'll pick an equation that doesn't have acceleration. So this last one, delta x is equal to initial velocity plus final velocity over 2 times time. Or if we plug in all the variables, initial velocity is 0, final velocity is 25 over 2 times 2. Again, 2 and 2 cancels out, right? Because we multiply and divide by 2. So it's 25 meters as our final answer is our displacement. So that's the first part. Now, let's talk about finding the acceleration. So let's say, for example, we didn't know the displacement. The displacement was something we didn't care about, and we just wanted to solve the acceleration, right? So now that we don't care about the displacement, but we want to solve for acceleration, what is the variable, what is the equation that doesn't have the displacement? Remember to stay hydrated. Hopefully you said the first one. So final velocity is equal to initial plus AT. So let's plug everything in and find our acceleration. So final velocity is 25. Initial is 0, so it cancels out. And acceleration is, oh, that's what we're trying to find. And time is 2. So to cancel out 2 on the right hand side, you need to divide by 2 on both sides. So 25 divided by 2 will be 12.5 meters per second squared. So just like this, we solved our first problem in kinematics in 1 dimension. So not so hard as you see. Okay, now let's take a look at the next problem. So this would be a good time to take out a piece of paper and try to solve this on your own. And if you have any troubles, feel free to keep watching the video, but this would also be a good time to stop and kind of attempt this on your own. So let me write down the 5 variables that are given. Final, initial velocity, acceleration, time, and right. And by the way, you don't need to memorize what these equations are, right? Like you can just read the first 5 variables here on your formula sheet, which you will be surely given in class. So a driver is moving at a velocity of 25 meters per second. Okay, so he's firstly moving in this velocity, then something happens. So 25 meters per second is the initial velocity. And then sees a deer 15 meters in front of it. Okay, let's come back to this 15 meters in a second. The driver slams on the brakes, decelerating at an acceleration of 15 meters per second. So 15 meters per second. Now remember, acceleration, sorry, my 5s are weird. Acceleration can be positive or negative because it's a vector. In this case, he's decelerating, so acceleration is negative. Will the driver be able to stop before he hits the deer? So this question that in this question, they're not asking for a variable directly, right? Meaning that they're not asking you what is the time, right? Or what is the velocity. They're asking, will he hit the deer? So we need to translate that into kind of finding what variable they want us to find. So I said we'll come back to this 15 meters in front of it because what really matters is whether the driver will, if his stopping distance will be greater than 15 meters, right? Then he will hit the deer surely, or if he will start before this 15 meters. So what we're looking for actually is delta x, right? And which will later compare to this 15 meters. So I'm not going to write down my 15 meters right here because this is the information for the driver. Now, okay, I'm given two variables here, but I always need three to solve for the problem. So something is here is coded in this problem that we haven't written down. And that's of course the final velocity, right? Because we're talking about driver stopping in the end. So final velocity is 0. Okay. Now that we wrote this down, and of course acceleration ends up being, or time, sorry, ends up being something we don't care about, this would be a good time to look at these equations, pick the right equation. You can stop the video, plug in all the right numbers, solve it, and then scroll forward to see if you get the same number. Or of course, feel free to watch this. And as we pick the equation without time, right? Since that's the variable we don't care about. So final velocity squared is equal to initial velocity squared plus a delta x. Now, final velocity is 0. Initial velocity is 25. 2. Acceleration is negative 15. And delta x over here. Let me subtract 25 squared on both sides. 2 times negative 15 is negative 30. And then I'll just divide by negative 30. Oops. Let me get rid of these equations now that we have selected one. Negative 25 squared over negative 30 delta x will be equal to, let me take a look, 20.8 meters. So comparing it to 15 meters, will he hit the deer or not? Well, unfortunately, the deer will be hit, right? Because 20.8 meters is greater than 15 meters. Now, in the next video, we will go over free fall motion. So what happens when objects are thrown in the air. So keep watching it if you want to know how to solve problems for the free fall. And thank you for watching. Have a good day.